Hello everybody. In this video we're going to go ahead and we're going to start talking about inheritance. So inheritance is one of the core characteristics of object-oriented programming. Inheritance allows you to create new class objects that reuse and extend existing class objects. The idea behind inheritance is to encapsulate like properties and functionalities so that you have a shared base template for other objects. Now, just a note here, we are talking about class objects. Structs, as an example, do not support inheritance. So anything that we talk about here is only definitely applied to classes. Anything else as far as object types go, and it's hit or miss, or it just doesn't support inheritance at all. So let's go ahead and start here. We're going to create a new class called animal. Now let's take a class animal here. Animal is what would be our base class. From this class, all other animals would be derived classes. Derived classes are, conceptually, different specializations of the base class. In the case of animal, logical derived classes would be dog, cat, horse. Now you go ahead and create a derived class like so. You define it as a class, give it its name, and then colon. And colon, this is how you signal that I'm about to inherit from another class. I'm going to say, let's inherit from animal. So now dog inherits from animal. All of the properties and methods that are not private, that are part of animal, dog will have access to. So inheritance also allows you to go several levels deep when it comes to deriving classes. Keeping with the animal example, if I then decided I needed to differentiate between poodle and Great Dane, I could inherit from dog. That would look like this. Class poodle comes from dog, and class Great Dane comes from dog. Now, as far as inheritance goes, you can only inherit from one base class. Your derived classes cannot go ahead and inherit from multiple base classes all at once by adding on different classes like so with multiple colons. You can only have one base class per derived class, but you can go ahead and keep inheriting further down the chain. Poodle, in this case, would have access to all non-private properties and functions of dog and all non-private functions and properties of animal. Poodle will get the best of everything. Now, one of the advantages of inheritance is shared properties and functionality. Let's take a look at adding 3 properties to our base class, animal, and how they affect the derived classes. So I'm going to go ahead and I'm going to create a private int, a protected int, and a public int. Now let's go ahead and let's go to dog. And in dog, I can go ahead and say this. Oh, rather we have to do this in the constructor. So let's add a constructor method to dog. And now this dot. Now notice, I have access to the B and the C variables. These come from animal. I inherited them from animal. And I have B and C. B is protected. C is public. We'll get into this in a second, but what this means is that I can go ahead and from dog, I can modify, I can read, I can write, I can do whatever I would as if these properties, int B and int C, were created within dog. They're inherited though from animal. And down here in poodle, if we were to add a constructor for poodle, this dot also has access to B and C. Again, it inherited from dog, which inherited from animal, B and C. Those 2 variables will you'll be able to access them because they are protected and public. All right. Now, let's talk about why I can go ahead and access those. Private variables remain private despite inheritance. The variable is only accessible within the class it is declared in. So private is honored. If it is a private variable or a private method, it will only be accessible within the class within which it is defined. Protected variables are accessible by derived classes. What a protected variable does is, well, let's go ahead and see here. If I went up and I created an instance of dog, and then dog dot. Dog has access to C when I'm creating an instance of it. Okay? That's because C is a public variable that is inherited from animal. C is the only variable, the only property that is public and that is accessible outside of the class definition. So private variables are only accessible within the class within which they are defined. Protected variables are only accessible within the class within which they are defined and any derived classes. So like we saw, I can go ahead and access B, and I can access C. Public variables, they remain exactly as you think they are. They're publicly accessible, both within the class and within any instance of the class that you define elsewhere. Now, as you can see, I can modify the public property, but not the protected. Protected properties, again, are only accessible in the base classes. Okay. Now, let's go down here to Poodle. What will Poodle have access to? Okay, we said B and C. B is the protected variable, and C is the public variable. It's protected down the chain from animal to dog to poodle. Any protected variable or method will be accessible. Okay? So the same goes for classes derived deeper down the chain. You will be able to have access to them through the root basis properties in the same way. Now the same goes for methods. Methods can be declared as public and private. So let's go ahead and in animal here, let's create a private void hello world private. We'll just do console.writeLine I am private. Okay. And then we're going to create a protected copy of this. Hello world protected. I'll call this protected. I'm not going to go ahead and do a public example. Public works exactly as you think it does. It's accessible both within the class, outside of the class, in any derived classes. Okay. And then we go ahead and let's go to dog. Now I have my private and protected methods here. Down in dog, where I have gone ahead and I put this in dog, let's move this out. Okay. This should be up here in animal, my apologies. So animal has hello world private, hello world protected. Leave this on the screen so everybody can soak it in, see exactly the mistake I made and what I meant to do here. Animal has these two methods. Dog should only have its constructor. And now in dog, let's go ahead and go this dot. And you'll see I have hello world protected, and that's the only hello world method I have. That is because hello world is a protected method, meaning it can be accessed and utilized by the base class from which it was created in, and any derived classes. If I were to go down here to Poodle, this dot hello world protected. Notice none of them had access to the private method, which remains private. It is only accessible within class animal. And if I go up here and I call dog dot, I don't have access to the hello world protected or private because they are private and protected. Okay? The protected one is only accessible from within the class, not from within an instance of the class. Now, sometimes you want to define a base class that you don't want that base class to be instantiable on its own. You only want it to be inheritable. What I mean by that is animal equals new animal. Let's say that I don't want somebody to be able to create an animal. I want animal to exist as a base class that I can then use to derive classes from, but I don't want another developer to be able to go ahead and create an instance of animal. That is where the abstract keyword comes into play. If you go up here and just add the keyword abstract class animal, it'll now, up in the main method, make that call to new animal little red squiggly telling you it's an error, cannot create an instance of the abstract class or interface animal. If a class is abstract, okay, I want you to think of the literal word abstract. It now means that this class it doesn't actually exist. It's just a concept. Okay? I can't create something from just a concept. I need more than that. So now that class animal is abstract, I cannot go ahead and create instances of it on its own. Now let's say I want to go ahead and make a class that can't be inherited. Okay? I want it to be that when you get to dog, you can't inherit any further. Okay? I don't want to be able to do further specializations. I don't want other programmers who are working in my code to derive things from dog and therefore lock it in so that if I change dog, I might break their code down the line. Or I don't want to do that to myself. I want to make sure I remember dog needs to remain as is. And that is where the sealed keyword comes into play. Saying it is sealed, okay, goes ahead and means this is locked in. This is as far down the inheritance chain as I can go. You'll notice now that both Poodle and Great Dane, the little red squiggly under the inherited dog class, Poodle, cannot derive from sealed type dog. Say the same thing here. All the properties and methods become errors as well for trying to call them. Yeah. So that is how you go ahead and set up some basic inheritance and how you do things like make variables and methods still remain only accessible to the class in which they are written, how you make them accessible only within the class they are written or within their derived classes, and how you continue to make them accessible all over the place. So private, protected, and public. In the next couple of videos, we'll go ahead and talk more about the concept of a base and derived class, and we'll get into a more in-depth example of how those things will work, and prepare ourselves for talking about things like polymorphism.